In this video, we'll start to look at how we can examine relationships in our data. Usually, when we look for a relationship between two variables, we want to use one variable to try to predict the other. We call the former the explanatory variable, and the latter, the thing we want to predict, we call the response variable. You may have heard these called the independent variable and the dependent variable in science, but we usually use the terms explanatory and response in statistics because we may have no control over the explanatory variable. To figure out how to show the relationships between the two variables, we need to know whether the explanatory and response variables are categorical or quantitative. Each case leads to a different way of displaying and analyzing the data. First, let's look at categorical to quantitative relationships. One of the most famous data sets in history is a collection of 50 records about 3 different species of iris flowers, Iris setosa, Iris versicolor, and Iris virginica, cataloging the petal length and width as well as the sepal length and width of each plant. Anyone learning about data science will probably run into the iris dataset at some point. We can use the species of flower as a categorical explanatory variable and any of these measurements as a quantitative response variable. One way to compare those variables is by creating side-by-side box plots. Here we have a comparison of the sepal lengths in centimeters for the 3 different species. Using the box plots, we can compare things like the medians, the quartiles, the ranges, and the interquartile ranges. Take a moment to pause the video and see what observations you can make. Next, let's look at categorical relationships. In 1912, the RMS Titanic famously sank, and more than half of the 2,000 aboard died, which included first class, second class, and third class passengers, as well as crew members. With a statistical mindset, we might investigate if there's a relationship between the class of the passengers and the survival rate. Here's how we might do it with a two-way table. In this case, we've got class as a categorical explanatory variable for the rows, and survival status as a categorical response variable for the columns. Note that even though class is designated with a number, first, second, third, it's still a categorical variable because there's no quantitative relationship between the different classes. To get a better idea of what's going on, we can add totals to the rows, the columns, and the whole table. Once we've done that, we can calculate, for example, the conditional row percentages. Divide each cell by the total for that row, and that gives us a way to compare what proportion of each class survived. For example, 201 out of the 324 first-class passengers survived, which comes out to about 62%. We could also calculate conditional column percentages if we wanted instead, to determine what percentages of those who died came from each class. Try calculating some of the other conditional percentages yourself, and see what conclusions you might draw. Finally, let's look at quantitative relationships. It's often said that the key to financial success is a good education. But how do we actually investigate such a claim statistically? One place we could start is, of course, by collecting data. But another thing we could do is look for data that's already out there. One great place to find data is the website Kaggle, where you can explore user-generated datasets accumulated from publicly available sources. If you're looking to get into data science or machine learning, Kaggle is a great place to start. And they even have competitions you might want to look into. One dataset compares the per capita income of over 3,000 US counties to how many people earned associate's and bachelor's degrees. I grabbed this dataset and used Excel to generate a scatter plot of the data, using the percentage of people earning bachelor's degrees in 2015 to 2019 as a quantitative explanatory variable on the horizontal axis, and the per capita income in that county in 2021 as a quantitative response variable on the vertical axis. By the way, if you don't know, per capita income is just the total income of everyone in the county altogether divided by the total population. So really, it's just the mean income. Anyway, in a scatter plot, each point of data is a single point on the graph. From the data, we can see that there's a slight positive relationship between education level and income. In general, if a higher percentage of residents have a bachelor's degree, then the per capita income tends to be higher, though with considerable variation. By the way, see the outlier at the very top with over $300,000 for its per capita income? That's Teton County in Wyoming, which I hope I'm pronouncing right. It has the highest concentration of wealth per household, more than any other county in the United States. We'll have more to say about this data set in the next video, when we dive a little further into scatterplots and see how we can describe these relationships quantitatively.